There we go. There we go, there we go, there we go. All right, let me get the chat window active if it'll load up. There we go. There we go. There we go, there we go, there we go. All right, let me get the chat window active if it'll load up. What's going on? That's weird. There it goes. Got it. All right. Oh, ah. All right. Yay. So the engine's out of the car. So the trans and everything. You see all the shit piled up behind it. Up there. What am I doing today? Today I am trying to make this stuff work. This work right here. Got it pretty much how I think it's going to be, how I want it to be. This is a SDI control arm using the factory rear mount, but I did what is usually called the caster mod. And the caster mod is where they take this and they unbolt it and they flip it around. This right here, this is a hard edge, not a soft edge like this side. This is normally on the arm side. You see evidence of the arm imprinted on it here. So you unbolt it, you flip it around, and you bolt it back in. And what does that do? Well, this is off center of the bushing, this mounting point. And so when you flip it around, you actually push the arm out. It doesn't go forward or back, it pushes the arm out. Well, if you recall from an earlier video, this mounting point on this rack is a 1/4 inch out and a 1/4 inch up compared to where the factory GC subframe is. Now this is 2017 WRX subframe. I also have a brand new one right here on the ground below me. This thing is kind of slow. I should speed it up. Here's a brand new one, and I have another used one that's slightly bent in the back of the shop. So what I'm gonna do here is I'm gonna do everything I think with this one for now, and then I'm gonna swap it out once I know that everything's gonna work with the new clean one. And this didn't take too long. So this is what I've done so far. Trying to combat this 1/4 inch out and up. Well, what does that do? Well, if you think about this arm, if I go up, it's not a big deal. It adds a little bit of I don't really add anything. It just changes the angle that this arm rotates. The bad side of that is that if you tilt it back, imagine you tilt it back, when you hit a bump, then the tip of the control arm could very likely, it's going to swing on an arc towards the rear of the car a little bit, which means you hit a bump and the tire moves backwards. Now, it's not inches, we're talking, just like a little bit travel backwards, because I want to pick this up a smidge. So, but there's some backwards travel, which could affect toe. If I move this hub away from the tie rod, then that could cause the toe to come in. Now, if the tie rod itself is coming out of the rack and leaning forward to go to the point where it connects on the knuckle, then it moving backwards as it's moving up might actually zero the toe gain that it would have otherwise. And I don't know what it's going to be yet until I put it all together and take some measurements. Now, the other issue, if I move this out, right, we discussed that. Now I move it out. If I move it out a quarter inch, then this arm does this, right? Rotates in this direction, which means that ball joint goes back, right? See that? This goes out, and this point's the same, and this ball joint goes back, which shortens the wheelbase and reduces caster. If I have caster, the wheel, or the, sorry, the wheel, right? It's the kingpin angle or angled inclination of the hub that the tire rotates on is tilted back. That's a lot of caster, like BMWs do a lot of caster tilted way back. Vertical, which rotates vertically, is no caster. So if I have it like tilted back and then I push the bottom of this back more, then I reduce caster. So now by pushing this out, I've reduced caster. And Subarus don't have a lot of caster to begin with. Usually in the neighborhood of like 3.5 to 4 or so. Maybe that's wrong. Maybe less than that actually. I think 4.5 is what you do after you do a bunch of modifications. But they don't have a whole lot of caster to begin with. And the last thing I want to do is have less caster. My whole origin for doing this is for a little bit improved handling. Now, lower caster will tighten the turn radius. It'll make the car turn sharper. Less caster will also result in reduced steering pressure on the wheel. So I mean, there are technically some benefits if you look at those two as being benefits, but that's not what I'm too concerned about. I actually want more steering pressure on the wheel, which is why I'm going to the electronic rack in the first place. Electric rack, not electronic. I guess technically it's electronic too. Rack in the first place. How did I combat the caster issue, or the fact that this moved out a quarter inch? Well, I took this off, swung it around, and that pushed the arm out, which pushes that ball joint back forward again. And coincidentally, it's about a quarter inch of movement back here that you get, so it pretty much zeroes out this. Now that's awesome. I'm excited about that. The issue is with the GC, when you do this mod with this steering arm, it causes the arm to hit right up in here. You can delay it through right now. But you move it out and the arm hits the chassis. Body, we're going to call this part of it. Frame rail, whatever. So that sucks. Now you see here I got daylight there because I've clearanced this some. Now it hurts my heart to do it because I don't like denting things, but I did. And so I'm going to do it on the other side and show you guys I'm doing on the other side as I do it, so you can see what I had to do to compensate for that quarter inch up front and then the contact back here. And it doesn't involve any hammers, believe it or not. No hammers at all. So that's good, right? But it still makes dents. But the cool thing is it puts the dent only where you need it, only in the exact location that the arm would contact the chassis. It won't now. It's got enough room now, unless I get some serious bumps or something. But now in casual driving and speed bumps and stuff, it won't hit. Yeah. That's what I'm going to do there. I'm going to do the other side. And after I do the other side, the lower arm, I am going to put the knuckles back in place, and then I'm going to screw around with the tie rods. see if the tie rods I got are too long or too short, if they're going to fit, and all of that. If you recall from previous videos, I had some issues getting the correct tie rods because they don't technically make them for this car. They're this length, or the correct length and correct thread pitch. They go into the rack. Do that. I'm not going to boots on the rack right now, so it's going to be goofy with no boot because I'm just trying to get geometry. I'm trying to verify that the things I did in Sawworks are going to pan out in real life, and we get. And then my goal for this car is to get it back together, get the electric steering working on the McPherson strut setup. Not doing the wishbones on this car. What I'm going to do is get this car running again and bring in the chassis that's not running and put on a lift and do all the cutting and everything on that chassis. I'm pretty confident now that it's going to fit. I think it actually might work with a RX-8 upper control arm and a Tesla Model 3 lower foot on the strut and an adapter for the lower control arm. I'm using this point here and section here to bolt the adapter onto it. It also might work with a totally custom upper arm, which I'm not opposed to doing. I have the RX-8 control arm, and I'll show you guys that in a little while. As I get this knuckle in here, show you how it sits in there with the knuckle in place, and we'll see together if it's the right length or not. I think it's a little on the short side actually, which might work out. There's a couple different philosophies on how to attach the upper arm to the knuckle and make that all work. So I'm going to screw around with some of that. And when I can, I'm going to answer chat questions and messages. And other than that, I'm just going to keep working on stuff. I wish I could do like a time lapse, but I can't time lapse real life. You know, I've often said I wish real life had a DVR because there's so many things that have happened and there's no recordings happening. Oh man, if I could only hear that one more time, see that one more time, it'd be awesome. Oh, and I'm also going to grab my my billet top hats, my Oscar top hats, and push them into the top of the car here and see how well they fit. I guess I could just force it. Makes it a little better if I go left and then force it. Tell it, hey, we're going left, and we're going down. All right. My fingernails look good. My voice is too low. But you know what? I did turn down the audio because I was in a dyno cell last. Oops, that's the wrong scroll. That's not the scroll I wanted. What do I want? Oh, this guy. There we go. That should work. Now the audio is coming out of the camera that I'm holding. Whoa, into the matrix. All right. So anyways, I'm going to work on this guy on the other side. Let me set this camera down and see what I can happen. Excuse me. I also need to organize some stuff in my shop too. Hey Matt. Hey Paul. Grab the nails, work on it for you. Alright. Grab my toolbox over here.
All right, I need to take this guy off. But I'm just
going to bolt this to the car first, so that the car will hold the arm for me while I try and loosen it.
So I have double audio, but I muted audio. La 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 la. Oh, that one too.
Oh, there's 3 audio sources? Wow. Who said yo? Hey, Curtis. Come on. All you need to bend that. I need 17. And probably a big ass ratchet. That's why I wanted to hold it to the car, because they're really tight. All right, so I'm going to show you again. If you look, you can see here, well, see how this mounting point, this flange, is closer to the center. So if I flip it around and I mount it on here, now it's pushed away from the center. It's not quite a full 1/4 inch, but it's definitely more than nothing, which will help reduce that effect that I'm going to have of the front getting pushed out. Now we'll widen my track a little bit, teeny bit. And these cars don't really have a whole lot of room to go as it is. Fenders are rolled already and all of that. But if you have a GD based car, with the aluminum control arms, and you haven't seen this yet, well, there you go, free caster. Probably won't be able to put this on. And let's see what side's up on this thing. I think it's the flat side. Yeah, flat side. Oh, okay, and there's a taper in here. So I'm gonna do it one way. Now, pull this off. want those later. All right, so I want to mount the actual mount itself rigidly in the car, but I don't want to tighten the arm up rigidly because I need the arm to be able to move around like this. And if I tighten this back nut on here, the arm's gonna be like this, not want to go anywhere. Some people put poly bushings in there to help the rear pivot. You can do that. Not necessarily anything wrong with it. That just crooked as shit. But you have to use poly, so you would increase NVH, and you can create stiction. You know what I'm talking about. Basically, what happens is the bushing slides, but it grabs at all the little points. When it stops moving, it grabs and sticks. And so you start to get the little noises from the suspension, some pops, some creaks, often squeaks when it dries out, all that kind of stuff. So I don't like that. I like the rubber bushing with the crush tube in the middle, and the rubber distorts and bends around that crush tube compared to the outer housing, which does add spring load. It does add spring rate to the arm. I mean, you can see right there on this one, right? It's bolted in tight, and I can force it to move some, you know, inside the bushing, but I got to give it a lot of oomph. And really, it probably shouldn't move in the bushing, but it is. Anyway, you see how much harder that is. There's quite a bit more spring rate in there, and you will see that spring rate in the wheel. Same goes for the bushings in the rear. Any of your rear rubberized bushings, they add spring rate to the car. Oh, there's my things. Oh, good. I thought they were in the back seat of the car. Test fit these. This was a project I started a long time ago, and I built the prototypes and then just kind of stopped. So I'm going to test these and see if these fit in the car in a few minutes. And I got a question. Are you going to change anything on the rear suspension? Yes. Yes, I am. I'm doing the whole rear subframe. I got that back from powder coating week before last, I think. So I'm going to do the subframe and the new coilovers. So I got to climb in the car and get those coilovers out. I have the new Fortunes. I'm taking out the Bilsteins coilovers. Taking those out because they were just way too aggressive for a car that weighs as little as this car does. They're technically GD chassis coilovers because I have the GD struts and everything. So on the front, I need to use GD. On the rear, I could probably get away with GC if I just bought GC altogether. Maybe backwards on it. I forget which one has the bigger hub, the front or the rear, when you have 5x114, because it's 5x114. So it limits what you can bolt to it. So I got new ones from Fortune. I told them what car I have. I have no idea if they're going to be good or not. They usually are. All the Fortunes I've had so far have been wonderful. We just put a set in Chase's Corvette. It drives great. My Corvette drives great. Customers' cars that run the Fortunes, they drive great. We always do the Hypercoa spring upgrade because Hypercoa and Eibach are the only two springs you should ever run in your car. Fuck Swift right in the ear. They're terrible. Yeah, so I'll be doing that. But I'm not doing anything fancy back there. I have TSS subframe, TSS lateral links. I have, oh, I should have those powder coated. I forgot. I had their trailing arms too. I took them out because the bushings were wearing out, and I was trying to troubleshoot a noise in the back of the car. Turns out it wasn't those, but it was a noise nonetheless. And I took them out during that troubleshooting. I was also trying to figure out this resonance that the car was getting on the highway in a certain spot, like this 5-mile stretch of I-90, the car would just start to bounce in the rear. It would just do this and just oscillate down the road. Whole car would just, it was just perfect. It was a perfect resonance with the speed. If I was doing 72 miles an hour, it was the worst. To the point where eventually my moob started shaking, my tits were bouncing, right? It was just unbearable. I've gone so far as to get out of my seat and sit on the center console for a while because the spring in the seat was also adding to the resonance, and I was just ring, 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 ring. So I sat on the center console and just cried for like an hour driving on the highway, you know. Obviously not an hour because it's only like 5 to 10 miles, but it just sits there and just whoop, 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 every day, to and from work, driving me crazy. So I was pulling out sway bars, I was changing spring rates, I was changing control arms, I was changing bushings, changed the alignment, I changed the ride height, and nothing worked. Nothing. And I still don't know what the fuck it is, right? Just nothing worked. I think it was the Bilsteins were just too damn stiff because they were very stiff. The damping was just way overdone on them. For my light, like I said, my light car, it was just too much damping. I mean, they were damped for a car that weighs 600 pounds more than this car, and that makes a difference. That makes a difference. So I'm hoping the feels don't do that. If they do, then that means it's the chassis. That means that the chassis is just getting too weak on the car, and it's like bending in the middle. And if that's what it's doing, then that's what it's doing. I plan on reinforcing the chassis anyways. So, yeah. What was I doing? Oh yeah, the rear. Where is that other washer? I bet it's in the house. I think the other washer and nut are in the house. Sorry, I don't need them. I still gotta get this. So I have to get this bolt in straight on this bushing. Oh, that's the wrong side. Oh, you bitch! Why won't you line up? Tiny stick. Come on. These always suck. These have always been just a bitch to start. There we go. That's straight. That's straight. All right. I made sure they were in multiple threads before I hit them with the juice, because last thing I want to do is change threads on the chassis. Ugh. Can't imagine that being fun. All right, so now with the camera, I'm going to show you the interference that we have, and then I'm going to show you how we're going to get rid of it. All right, so which way does it go? This way. All right. All right. When this arm moves outward, bonk, right there. I can't move it up, and the arm is just about level, and it's hitting right there. So, what do? Well, the first thing I do is just utilize the fact that it's round. It's a round arm. I'm going to push up on it. Ugh. That's as far up as it will go. You'll see the control arm here is contacting here, but also it's really, really vertical. So I would hope to God it never hits that kind of bump. So we're good there. So I have some travel in here now, but there's still this tight spot right about here when the arm is about level. Sorry, right about here. So what I did is I grabbed one of my LS rocker spacers. I folded it up, and you see the impact mark here on the arm. I just put it right here on the spot, and then pinch it. And I got about, what is that, 100 thou worth of shim there. Fold it up. I'm just gonna push it again. Ugh. And I'm just denting the chassis just a little bit, right where that fits. Just a little bit of force. Move this back to this area and just work it down some. And it's a pretty hokey way of doing it, but it's, honestly, it's kind of also elegant in that I'm only clearing what I need to clear. I'm not banging on stuff, and I get a nice round shape out of it. I don't have this multiple dents and impacts against the chassis. No hammer marks, none of that. So I'll just put this on here again. Push it up. And it just bends enough. Look at that. Let's see if I can show you there. There we go. There's room in there. There's daylight. There's a good amount of room. The chassis is usually going to sit around here-ish. So it's going to have lots of clearance, and then it goes up. I have lots of room. So that was it. I just used this little shim, and since this is round, and I had all the leverage I needed with the control arm, just sandwich it in there and smoosh it out. And the result is, if I can get through here without the camera. Oh good, there's a nice bright light behind it. That makes it easy to see. Let's see. Do it from the front. Like this. See if I can get it in there. You can see right there. So that's where I dented it. Just a little bit. It's not a lot. Right here. But it did just push this ridge in some. I see a little bit of potentially exposed paint. I see primer. I don't see exposed metal, but I'll probably clean it up and shoot some undercoat on it or something just to make sure I don't have any rusting spot. But yeah, that was that's my hokey fix for clearancing this. But now it moves all the way until it hits the subframe with clearance. Yeah, lots of clearance. So that's that. I got my little phone thing here, way dirty. All right, so now I'm gonna grab a knuckle. Actually, I'm gonna lower the car down. Lower the car down and grab the knuckle for the driver's side and start putting that in. I'm not gonna put the strut in yet. I'm just gonna do the knuckle first so I can show you guys the RX-8 control arm and all of that. Set this back down. Wobble in a rim barrel. I don't know what that means. Hey Caitlin, how you doing? Miss you. Half cage should be just stiffened up. Yeah, that is kind of the plan. I didn't want to do a whole lot of interior caging. I was potentially going to get rid of the back seat and just put like a shelf back there. 6 over Crest, they have a kit that eliminates the back seat and has like a little storage shelf there, so I thought about getting that. And what I wanted to do is first I'm going to weld a bar between the strut towers near the top of them. When I got rid of the rear strut tower brace on the car, troubleshooting the noise, again like I was saying, it had an immediate effect on the handling of the car. The rear strut tower brace on the GC absolutely makes a difference. I don't know who else maybe. Oh no, they're brand new. brand new wheels, and I went to different wheels and tires too. I seriously did everything. The wheels that are on it, that were on it, were my '07 STI wheels, which only had like 12,000 miles on them, near immaculate condition because I took them off when they were almost new and put different wheels on the car, on the STI when I had it, and they're in beautiful shape. Not even a scratch on them. And then the other wheels I put on were brand new wheels with hub-centric rings and everything, and snow tires even. And the snow tires helped absorb some of it, but it was the same. And I did another set of wheels and tires with different snow tires on it, and I changed pressures in all of the different sets of wheels and tires, and all of that, and it hardly had any effect. So. Yeah, and it's the whole car like going up and down. It's not like just like one corner. The whole thing just starts to bounce, and it's not really. It feels like it's flexing, almost like I said, like a spring, just hanging on. Wow, 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 wow. There's this frequency that it picks up, or it almost feels like it's bouncing front to rear. You know, the way it oscillates, front to rear tires, and it was like the road had just the perfect amount of give to it. Oh yeah, yeah. This is not. It isn't just a wobble. This is the entire car bouncing. It's one of those things where if you see the car on the highway, you're like, this fucking poor bastard, because the car is bouncing down the highway. It was visible from the outside of the car, just doing this. It wasn't subtle by any fucking stretch. It wasn't subtle at all. It was significant. The whole car, and like I said, it was visible. I had a friend or my wife take a little picture of it, a little video of it, and you can even see that the wheel gap going on front and rear, and they were out of sync. That's why I felt like the car was going back and forth, front to rear. It was totally fucked. But yeah, I went through everything. I went from way low on the car to way lifted, and in between. Like I said, wheels and tires, different control arms, different sway bars, different pressures, different damping. Because I'm pretty sure the Feels did it too. But the Bilsteins did it worse than the Feels I took off for the Bilsteins. So, no, it was way too much damping. It was almost bouncing on the tires. It was way too much damping. It was, yeah. Not enough damping. My ass, holy shit. You should ride in this car with these fucking Bilsteins on there. There's way too much damping. I even went down to a 3K spring on it because the damping was so overdone. Trying to get the car to have some compliance and not feel the paint on the road. But like it was so stiff, you felt the paint, you felt every pebble, every crack, every gravel, everything was bone jarring. It was way over damped. So, all right. Oh yeah, knuckle. Okay, driver's side knuckle. This one. Might hit that jack handle. Let's see. Or I'm a safety Nazi. I always go on the locks. I don't ever rely on the hydraulics on a lift. Never rely on the hydraulics because I don't trust them. And especially when you get a 10K lift for $1,600, it might not be a good idea to trust it. I don't know. Come on, little ball joint. Oh, bolt's still in it. one thing with not having enough load on it. I get the ball joint seated without any load on it. It's kind of hard. It's close though. Let me get my bigger purse. There we go. Alright, so I just want to look at some stuff really quick. So I'm getting my magnetic level, this little guy, and I'm going to stick it on the hub and put the hub vertical. Now I realize it's not totally at right height, but it's pretty close. That arm angle is about what's going to be at right height. And I'm going to set the, oh, that is dead. It's flashing 1 at me. Now it's flashing 2 at me. Okay. Is that level? I mean, maybe. Okay. That's weird. All right, anyway, so I'm gonna try and get the hub vertical on it. And then I'm just gonna eyeball what my kingpin angle is. Maybe use this to get a slight measurement. Wow, I was close. I got that within 0.7 degrees. Just sitting here. There we go. Stay. Move a little bit. That's a significant angle. So straight lining basically from this ball joint fulcrum in the bottom of the hub to the center of the strut would give you your angle. Now obviously I'm not going to get that by holding this in the air, but I'm just showing you, like, if I had a straight line from here up center of the strut, that's your angle of inclination. And this looks like it's like 13 degrees, which actually isn't that far off of what McPherson strut setups usually are. They're usually around 16 degrees on a McPherson strut setup. So I want less though. I want less of that. Why do I want less? I want less because the more kingpin angle you have, the more camber you lose when you turn the wheel. So if I have my angle, and this is the contact patch of the tire, like the tire, right? If I have it tilted in, so a lot of angle in, actually the same direction as the car, with the driver's side. So I tilt it in on the driver's side. As I turn the wheel, what you see is the tip of this hammer drops down, right? Your tire does the same thing. The tire drops down, which increases steering pressure, lifts the car. That's how it increases steering pressure. It lifts the car up, right? The tire pushes down as I rotate it. The ground's not going to go down, so the car's going to go up. So if it's tilted in a lot, I turn right, I lift the car, increases steering pressure, but also that tire that has camber here, as I rotate it, it loses camber. Because this isn't tipped back, this is vertical and in. So as I rotate off of an inward angle, I'm rotating towards vertical. So I lose camber as I turn in. And I don't want to lose camber as I turn in, because when you turn in is when you need most camber. So then you add caster. You tip it backwards towards me now. I'm adding caster to it back to me. So that ideally, if it's at an angle on 2 planes, I rotate that tire. I mean, and even it still drops down. Not as much. It still drops down. But then, even if it was 90 degrees, it would still have the same camber, right? Because it's turning now on this other plane. So if I have it in and back, as I turn in, I keep camber, I maintain camber. Now, if I reduce this inclination angle, the kingpin angle, and maintain caster, and I turn in, I gain camber. And that would be ideal. So what I really want to do is I want to have like way less inclination, because you know, if I have 16 degrees of kingpin angle, I would need like 16 degrees of caster for it to not lose camber when I turn in, because I want camber gain or camber sustain. So I can't have 16 degrees of caster. That just ain't gonna freaking happen. But if I could get 4.5 degrees of caster, which is typical on a car like this, but I can reduce my inclination angle to within a few degrees of that, then that means when I turn the wheel, I don't lose camber. That's why when you see like BMWs, they have a ton of caster on those things, because they also have some inclination, not as much inclination, but they have a lot of caster. And when you see them turn their wheels, looks like the tire like falls over in the wheel well, right? Because it's gaining camber as it turns. This will never have that kind of geometry, and I mean, I wish it would, obviously, but I want to get as good geometry as I can out of it. Now, with the McPherson strut, I'm not going to get anything better than that. And really, when I increased the wheel track of the car, the track width, that upper strut mount is in the same location. So if that upper strut mount's in the same location, and I push the wheel out, right, that angle is still not very good. And I can adjust the hub at the end, and I did. I had camber bolts, 2 sets of them, to kind of push this vertical some, but that only helps so much because the point of rotation is still up here. It just kind of changes it. It actually makes it kind of swing around instead of turning on the pin on the axis, which isn't very good either. So ideally, with an increase in track width, you would actually take your struts and move them out. So ideally, I'd want to go out with the strut and back with the strut to help match that increase in width. And that would reduce kingpin angle and increase caster. And then rely on camber bolts and other geometry things to try and get the camber that I want. A lot of guys take that strut top and they dive it in and get a bunch of camber out of it. But then that rotation, that plane for that kingpin angle has just gone up. And so that when they turn in, they lose even more camber. So just a little something. So I really would want to go backwards and out a smidge if I could to help reduce the kingpin angle, which is already too high on a McPherson strut setup for what I got, if possible. So it isn't. What I'm going to do is put wishbones on it eventually. Like I said, I'm going to put this car back together, get it running. I got some of the geometry shit I want off of it. I have the RX-8 control arm, which I said I may or may not keep. I'm still not sure. But I'm going to pull the other GC in after this one's running again. And I'm going to do the wishbones on that and get that all squared away so that I know what I need to do in the future to get it for any other GCs. Or GDs for that matter. I'm also doing on this one with electric steering, I have to do the column. I have the 07 STI column, which has a steering angle sensor in it, which I can feed via CAN bus to the ECU and to the steering computer for the thing. And I have, well, I have an M-Tron, which has a functioning CAN bus, so I can feed it TPS, RPM, vehicle speed, and all that right into the computer for it, and that will give me a good amount of control over the steering system. I can bias those readings if I want to change how much assist I get. I can basically scale the output to have it provide me less assistance at higher RPM like it would, but also a little extra down low RPM, or not low RPM, at low speeds when I'm in parking lots and stuff. So that's why I did that. The other reason I did this is because I want to get rid of the hydraulic power steering system. I don't want the hydraulics on this car because I want to use that spot, that real estate, for something important. I want to utilize that location for an oil pump so I can do a low mount turbo and pump the oil out with the power steering pump, or at least with a pump located in the power steering pump position. Then I don't have to worry about electric scavenging pumps that suck. They make a lot of noise, they're loud, they don't have adjustable flow rates, they aerate the oil, they just cause a bunch of shit, they're unreliable, they fail. You know, I don't want any of that. If I use the power steering pump, I can pop a couple fins out if I want of the pump itself to reduce the chambers in it, give it a little bit of bleed off, reduce how effective it is, which is fine. But also, even if I don't do that, whether I do that or not, I still have a pump that turns with engine speed. And engine speed is a much closer representation of oil load to the turbo than anything else. So I'm going to put, I think I can make the power steering pump engine oil and pull it out of the turbo. Now people have asked, well, what about the whining sound? It's not going to whine. It's not going to whine because the discharge isn't 200 psi, right? Or more like it is in the power steering system. I'm not going to have any discharge pressure. It's just going to move fluid from, it's going to have some suction. It's going to discharge it into the PCV system or into a valve cover. So I'm not going to have a whine from it because it's not loading up and pumping air through a tiny spot. It's not going to do any of that. And if it does, I'll figure a way not to. Whether I got to pull the relief out, which is probably what's going to happen anyways, take the relief valve, the pressure regulation valve out of it so that it strictly just moves a volume of fluid and that's it, with no target pressure in mind, because I don't want it to have output pressure beyond what it takes to move the amount of fluid that it has. If you've never seen those things move fluid, they move a lot of fluid. If you've ever taken a power steering hose off the return, like at the reservoir, if you pull that sucker off and start the car, you can fill a gallon in seconds. So it will absolutely have the flow rate needed to do this job. So if I pop a couple fins out in a nice pattern around the rotor, then that could or should reduce the flow rate a little bit and make it a little closer to what the turbo is going to see, and I can kind of tailor it to that. If that doesn't work for some reason, I don't know why it wouldn't, then my dry sump pump system that I have is modular. Like I said, I made that thing modular. I can do it as a single chamber if I want. And a single chamber setup with a power steering pulley on it, you know, the same splines as a power steering pulley, I can make that fit right in the exact same spot. And then I have a pump that's made for pumping oil, and I can utilize that. So I have options. As long as I get rid of the hydraulic power steering in this car, I have options, and that's why I'm doing this. Also, the rack in my GC was toast. And I wanted to get a quick rack, but I didn't want it to be 15 STI quick. I want it to be, you know, it's a little slower than that, and the 15 WRX is perfect for that. It's still a really quick ratio, and that's great. In the end, if I end up changing the hubs on this, which I may do a fabricated hub, then I'm going to move the tie rod point in a smidge anyways, and that'll give me faster steering as well. It'll also help with bump steer when I go to add more caster to the car. When I tilt that plane, we're looking at it from the side of the car now, if I tilt that plane back, the hub, which is, you know, here, falls back, and so I would lose wheelbase on it, and that sucks. But what that also means is that the point where the tie rod connects falls back. Oh, actually, that's the wrong direction, isn't it? Yep, that's the wrong direction. I'd have to push the bottom forward, because that's what I was thinking before. I was going to push the bottom forward, and then I have to move the arm in. But if I'm doing the top back, that would make the arm not in the right location on the hub. So that's the challenge that I'll tackle when it comes time. Oh, arm. Let me get that arm for you. All right, so here is the RX-8 upper control arm. Now you'll see it's got a big open section in the middle, which I think would fit a strut. We're gonna find out. It's a left-hand arm, upper left, like this. This is how it will go in the car. Well, I guess from the driver's side, but from the direction you're looking, it goes in this way. It's got a big L stamped on it, but I'm pretty sure my coilover fit through there. So I'm going to grab the new coilover and make sure it fits through there. And I have to attach this somewhere above the frame rail. I got a kit from TSS Fab that he has brackets that are for doing this. Now, his brackets didn't specify like what vehicle it would work with, like for a control arm. So I have no idea if they're even the right length. I don't know if they're the right length or the right width or anything. Or if I have to do custom arms. I haven't even opened the kit up. I mean, it's still wrapped in plastic here, so I have no idea. I don't know if it's the right size bushing. I don't know anything. And, you know, like I said, I may have to do it my own or do my own adaptation or, you know, who knows. I just bought it because it was convenient. And he'd already done some stuff to it. So here's the box for the bushing, I assume. Look at that. That's the fucking right size anyways. Okay, this is the plate that he made that you weld onto the frame rail of the GC. This is made for the GC. But like I said, I never asked him what control arms it was for. So it's not wide enough for the RX-8 control arm as far as where it fits on this frame. Definitely not wide enough. But the little dog houses, these little guys, they're wide enough as far as fitting the... Oh, I see. So he has it set up for vertical bolts for heim joints. So he's got it set up for like a heim joint. You build your own arms and use heim joints for it, which makes sense. And the vertical bolt is kind of a cool idea, especially if you put threads in the frame. Then you could, you know, put it in like that. Obviously, it won't work on this, but yeah, I could also just drill holes in it and slide those in, and then space this one differently, further or back. I don't know how we design it. I haven't test fit it. I would have to cut through my fender liner and all that to test fit this, and I'm not ready to do that on this car. So anyways, that's the kit I have. It's kind of neat. Got little bushings that fit specific heim joints that he uses. So if I make my own upper arm, this kit's gonna be great. But not for use of this arm. So what angle do I want this arm here? So when I put it into the hub, or into the knuckle, if I have it slightly up, right, there's asymmetrical, there's all kinds of different geometries that you can use for a suspension based on what you want to get out of it. But if you want to have camber gain when you hit a bump, you need two things to happen, or one or the other, I guess. You need the bottom arm to be in droop so that when you hit a bump, it moves out and pushes the bottom of the tire out. Right? That would give you camber gain. That also can mess with your bump steer, so you gotta be careful about that. Now, if you think about where this is mounted here, and this ball joint, and if I just spun it on this mount, I have a circle, right? I get a circle out of it. Okay, so I get this big circle. Now, if I think about where this ball joint is on that circle as this arm travels, I can achieve certain suspension reaction, basically. So if it's in a big droop and I go up an inch, right, you can picture this circle. I'm on the bottom half of this circle almost. And a little bit of movement outward means, or a movement upward, gives us a lot of movement outward, right? A lot of movement. And 1 inch on a circle, on the bottom of the circle, is a big part of the arc. So if I go 1 inch higher, I got to go all the way up to here to get 1 inch higher, right? That's a lot of travel. And that's a lot of movement outward. So I would gain a ton of camber. But I would also have the nose of my tire do this. Whoop, and just turn in. Massive bump steer issue. Unless somehow I was able to get the top to come in the exact same amount, the same distance, to hold that tie rod in the same location, and then I want to get a bump steer. Well, how would I do that? Well, I can't have this arm being down also, because then they both go out together. So I have to have it the opposite direction, so that when it goes up, it moves in. So it's got to be in the upward stroke, right? To add more camber, to pull that point where the tie rod's connected and keep it in that plane. That's pretty tricky to do if you were having such extreme geometries. But when you have smaller geometries, my lower arm is only, a few degrees below bottom, and my upper arm is a few degrees, below horizontal, and my upper arm is a few degrees above horizontal. When it goes up, it's moving in, and when this one's going up, it's moving out. So you can make it so that the upper pulls in and the bottom pushes out, but the center pivots more, and you don't have as much bump steer. Or you can have the bottom completely square, just below, like just below, so that as it travels up and down, it's on the most vertical part of that circle, hardly any in and out movement. And if you think about it, bottom control arms are really long. They're like significantly longer than top arms. So the amount of travel that it's going to get without moving in and out is going to be significant. Like you're getting a lot of up-down travel without significant movements in and out. And if you have it slightly drooped and you hit a pretty good-sized bump, it's going to pass through the outer part of that arc and move back to the inner part, and your cumulative gain is going to be almost nothing or your bump steer is going to be almost nothing, as long as we were on the same plane with the steering arm. Now we tip that in some, and this goes up and down, okay? So we still have a little bit of forward and back, but then if we take this part and we move it in, as this moves out, then we get to rotate almost on that axis where that steering arm is. You have like no bump steer, which is really cool. And you get camber gain. The bottom comes up, pushes out, you gain camber. The top goes up and pulls in, and you gain camber. So you can gain camber with a bump and not have a lot of bump steer. The cool thing about that is a bump by itself isn't a situation where you want or care about camber. But when you're cornering a car and the chassis is leaning into it, that tire moves up into the wheel well, right? Now the car is rotating. One side's getting higher and lighter, the other side's starting to compress. Now, just by that movement of the car rotating and rocking, you lose camber on that outside tire. So if you have it come into the body and gain camber as the car's leaning over, you can maintain camber or even gain camber in a turn where you'd want it when the G-forces are high. So now I got camber gain turning the wheel that I get from my kingpin angle and my caster. Slightly more vertical kingpin, lots of caster. I turn the wheel, I gain camber. And then I'm gaining camber from my suspension movement as the car compresses. Does that make sense? Hope so. So that's the challenge with this project, is figuring out where I'm going to get it and how much I'm going to get it based on what adjustments I make. So ideally, I don't want this arm being at a crazy angle. And if you look at a lot of suspensions, you will see some where the upper control arm is like this, but a lot of them it's flat or even up a little bit. And you look at some Formula One cars, and the upper arms are often going up from the chassis up to the tires. There's a few cars that are downward, but the cars that are downward usually have the upper and lower arms a lot closer in length. And so what they end up having is just that the tire moves up and down and doesn't gain camber or caster, doesn't move out or in too far because the arms are so long, you're in that vertical part of the circle, there's not a whole lot happening. Or because they go such high speeds, a little bit of toe can mean a lot of steering. They have one arm that's a little bit shorter than the other on top, and it's just enough movement that when it comes up that the steering doesn't change drastically. Hope that explains it. Now, this guy, I have room to put it in my wheel well, you know, forward and back a lot. If I go back really far, I gain a lot of caster, which I wouldn't get with the strut setup. And that's great, but I tip my knuckle back and I lose some wheelbase. Not ideal. And I pull the tie rod connection point back too. Now right now with this rack, this point is forward of the rack. So some movement backwards is okay. I'm fine with if my wheel travels on a slant as it moves up towards the top of the chassis on this angle. I'm okay with that to some degree because I have that tie rod angle being forward, so it can straighten it, which would toe out normally. Can you model the camber curves and toe curves through full suspension travel in Sawworks? Yes, you can, and that's what I've been working on. The hard part is getting the data. You have to do a motion study, and then you have to take a plane and say this plane changes by 70 degrees as it goes up and down, which would be like the face of the hub or the face of the knuckle. And then you'd have to pick a point to show the forward and back travel of that point, or you do other planes, you do 3 planes, show where the planes move, or a point on the plane and then see where it goes. And I've been working on that. The issue I've been having is I've been trying to model all the other parts. Like I have this arm modeled in there. I have the lower arm modeled in there. I have the subframe modeled in there. What I didn't have though is I didn't have the knuckle yet. I didn't have the knuckle modeled yet, and I didn't have the point where the tie rod comes in very well. It was very fuzzy because the scanner doesn't like reflective metal, and I scanned the subframe with the rack in it, and it just kind of flipped out because it was a shiny silver piece of metal. So I can model it with a fat friend in the car named DZ. I don't think his name is DZ. But I don't want to have, 2 degrees of camber on one side and only 1 degree camber on the other. That's a fat joke. So the question is, how far back can I go with this arm and still use the upper mount point? Because ideally, what I want to do is I want to still use my struts. Now, not this strut, because you'll see here, this Bilstein strut here has the foot, it's all made as part of the lower part of the strut. Oh, don't be sad, Josh. I mean DZ. But most aftermarket coilovers, they're threaded, and the foot's threaded. So I can make my own foot for it, or use one that exists. And well, that's pretty worn out. That's brand new. Wow. That bearing is really wear out. And this is literally brand new. Like, this thing has got, shit, it's got no miles on it. It's got a couple thousand miles on it tops. And that bearing and that top hat is destroyed. How is that possible? Because it's a KYB top hat, not the factory top hat, probably. But I went with a factory style top hat, or I went with the Bilsteins because they use a factory style top hat. And I wanted to be able to bolt on mine. Wow, that is fucked. Look at this. Look at that. That bearing is toast. This literally has a couple thousand miles on it. It's dirty because I live on a dirt road. But god damn, seriously? And I don't even beat this thing. No, Josh, we have fortunes. You and I both have fortunes. I'm gonna grab one and show it to you. Show you it. I can't talk today. It's a good day to do a stream when you can't talk. This is the new Fortune 500. I think the version 8s, I think is what they're calling them. Their newest one, I believe, is the Gen 8 or version 8, whatever they call it. What you see here, though, is the body is threaded and the foot threads onto the end of it. So that means I could potentially get the Tesla Model 3 foot and screw it on. And the Tesla Model 3 foot is made to go around the axle. It's made to go around the axle, so it would go down and then go around the axle and attach to the lower control arm. This is really nice. Yeah, this is their new generation one. Boy, that's really nice. I like a washer. I like that the collars lock. Instead of having two collars that you pinch together, I really like that these have a lock. Now, that being said, if that strips out, then your day sucks. But I do like that they lock top and bottom. 5mm, 4mm. That's 4mm. It says on the side 4mm hex key, and this one says 5mm hex key on it. These springs are Hypercoa Springs. Just look up Tesla Model 3 coilovers, and you'll see it. Like I said earlier in the stream, Hypercoa and Ibach are the only two springs you should ever use. There's a lot of people on that Swift Spring bandwagon, and they're ass. They change shape, they change rate, they just alter themselves dramatically over use. When I put Swifts on this car, I had feels for it before I put the Bilsteins on, and I had to raise the back of the car 4 times in 5 weeks because the springs were just sacking out. Now some people go, oh, the spring has to settle some. Bullshit. There ain't a race team out there, Formula One, NASCAR, and that shit where they was like, oh, the spring's just settling, right? They don't hit the track and be like, oh, well, we got to do a couple 100 miles on this car first for the spring to settle in, and then we'll adjust the suspension some more. Like, no, that's not how it fucking works. So, anyone tells you the spring is just settling is just telling them they're full of shit. Hypercoas and Ibachs, they retain their shape, they retain their rate, they're the same length after you've used them for a while, whereas those Swift springs on my car were just getting shorter and shorter and shorter, and they weren't round anymore, they were starting to deform. They're just absolute shit. And their marketing, if you have any idea how a spring works, you read their marketing, it just shows you that they either think that you're all fucking idiots, or they are. I don't know which one it is, but they don't know how springs work, so. Yeah. But these don't change shape when you compress them. They don't change the length after a lot of use, and they're a good spring. So it's an upgrade. It's an expense that you pay a couple $100 more for these coils with the Hypercoa springs, but they're worth every penny. The Bilsteins, I really liked them because they had helper springs on there, and they had the fixed foot. Now, this is something a lot of people don't realize. The fixed foot is actually a superior design. I'll answer that question in a second. It's actually a superior design if it's done and modeled around the car. Now these, look, you see these are look how thick that is, right? They're an inverted strut. It's an excellent strut design. Helper springs. It's got Bilstein brand springs. I have no idea if they're good or not. I don't know if these things, you know, don't change shape or last a long time. Anything about the Bilstein springs, but they're known for having good products, and so I got these. And if it wasn't for the fact that they were damp for a car that was, you know, a quarter ton heavier or more than a quarter ton heavier, I think I would have stuck with them, because the inverted shock is really nice. Everything is just really nice. The helper, I love the helper spring. I love all that. The fixed foot. So I was saying that this is a superior design for a reason. If you properly build a suspension setup and you properly build your coils or your struts, your strut for the car, this length, or the compressed length, it isn't variable. It isn't some magic thing that you gotta, you know, oh, I don't know where to do it and move the foot up and down. That's bullshit, right? It isn't variable. When you compress the suspension, something in the chassis is gonna make contact. You saw that when I lifted that control arm, it hit the subframe. And it was up a bit, but it wasn't, you know, like vertical. So there's a limitation there. Now, if you picture, I hit a bump, and I hit that subframe with the control arm, that far off the control arm mount, do you think that control arm is going to be straight after that event? Probably not. Thin aluminum, thick steel, tons of leverage the tire has on it. I bang into that subframe, I bend the control arm, wreck the car, day's done. Alternatively, the axle, like a GD chassis, when guys lower their cars a bunch on a GD, you have to notch the frame where the axle goes, because the axle comes up and hits the frame. Some guys let the axle do it themselves, and they regret their day. I get this crazy vibration I can't figure out. Yeah, because your axle's doing this in the car. Tires, if it's the factory size tire, or diameter I should say, it's probably going to contact the fender at a very specific point every time. And so manufacturers of struts know this. They take the spring off, they push the suspension up to the top till something impacts, they figure out what that distance is, and they make sure that their shock bottoms out before the car does. You want the shock to end its travel before something in the chassis contacts something else and damages it, or breaks it and crashes you out, all right? So this distance, this compressed distance from the tip to this foot is known. And when you build a good strut for a car, you know what it's supposed to be. So this is superior in that it assures two things. One, again, safety-wise, right? But also, if my maximum or my minimum distance, my most compressed distance, the shortest the shock's going to be, is at the end of the travel, that means that all of the available travel is usable travel. Too many guys put coilovers on their car and lower it only by screwing the threads into the foot of the strut and lose over half of the available travel in their strut. They pick the car up in the air, and how much droop does it have? That much. How much bump does it have when it's at normal ride height and it can go up before it bottoms out? This much or something, right? They have things wrong. So the tire hits fender or whatever, right? So they only have like 1.5 inches of total suspension travel when they could have had a lot more droop. And droop is very handy when you're turning. Suddenly having this side of the car completely unload all of a sudden is not ideal. Going over bumps on the highway, having the car want to leave the ground is not ideal. There's a lot of things that having the strut go thunk to end its travel as you go over a bump and the car follows it down is not ideal. Having usable droop is. And so this is superior for a GD because it was made for a GD, and its length for a GD is superior because it bottoms out just before the car does, the suspension in the car does, before you hit a control arm or something. Now, you put in a GC, it's not the right length. It's not the right length. So in that situation, what I got from Fortune, which is a threaded foot, is perfect because my car is not a GD, but it uses a GD foot. So when I do this, I will have the spring off when I do the final setup. The spring will come off. I will compress the entire suspension up. I will bottom out whatever's going to bottom out in the car. Use a pencil jack and just screw it up, right, until something stops. And then I will see where that's at. I will lengthen the shock as necessary to have the shock now be bottomed out. I'll pull it off like a 1/4 inch from whenever it's hitting. And then I will lengthen the shock until the shock is fully compressed and bottomed out. Then I will lock the foot. That's the length of this lower foot now. And from then on, all my height adjustments will be done with the spring. Now, what does that mean? That means that there's a possibility that when I go full droop, the spring unloads. And no one likes hearing the spring unload. They don't like it. And so a lot of companies say, oh, preload the spring a 1/4 inch and then just adjust the foot. And that's what a lot of people say. And those companies are only appeasing you because you don't want to hear noise. But they're creating a situation where you're not getting as much suspension travel as you should have. And you don't have the safety factor that you should have. So how do you stop that? Well, that's what Bilstein did. They know that since their distance is correct, that you may need to adjust this spring perch to a point where when it does achieve full droop, you have more travel than the spring is long, and you unload the spring. So it's got a helper spring on it. See this helper spring here? This helper spring has like no spring rate. I mean, I'm basically pressing my hand a little bit. Okay, has no spring rate. Its job is just to keep pressure on this spring, keep this collar, and keep this spring centered, and keep it from becoming loose and rattling around inside the strut. So what am I going to do? After I determine the proper length of this, if I do find that in full droop I'm unloading the spring, I will acquire a collar and a spring. And it's super easy. Ibach has the catalog online. Hypercoa does too. It's not as good as a catalog. It's not easy to find stuff. Where you just measure the diameter of this. You get the collar that goes in between them. You order the helper spring. They're like $30. And then you take the top off of this. You slide the helper spring down. Turn the collar down the rest of the way. Put it back together again. And you have it. And you have a setup that's correct. Like, you have all the travel that you ever need. You have safety. And you have the shock operating in a range closer to the middle of its travel. I don't think I meant to go off on a rant about that, but I did. So, wouldn't moving the hub or the steering rack back mess up the Ackerman? Well, I mean, shit, everything we've talked about to some degree will mess up the Ackerman, right? I'm talking about going up, going back, going in, going out. Yeah, all that stuff has to be addressed. When the tire turns in, right? You know how I said that the rack is behind that point? That is also the same idea. I have this arm coming out and going forward some, and this is going to turn on a circle, right? And it's going to fall back as I turn. So when the tire is straight, the point of the tie rod is at the highest point of that circle, and I'm on this arc as I turn the tire, and that brings the tie rod down some as it goes on both sides. Okay, so I'm at the front and the end, and the idea is when I turn the wheel, I'm going towards this guy, and I'm bringing it down. What that means though is that the inside, as you turn into it, this is getting longer. So the outside tire that's turned towards the rack turns less. Does that make sense? On the other way, as I go away from it, it's also getting longer. But I have to use longer strings to show you that as the thing moves out and moves towards the hub as it rotates, then the outside actually turns a little bit more, or the inside turns a little bit more, which makes sense because for Ackerman, the front tires are on a tighter turning radius than the outside tires. So if I move this too far, so it's back, if I move the hub backwards like this and I straighten that arm out, then as I go to turn, the arm is getting shorter in both directions instead of longer. And yeah, I mean, that obviously would affect Ackerman, but we're talking about tons of different changes in the car, and absolutely. Did I answer the question? I mean, there's other things we can do with Ackerman too, or how we do it. So if our kingpin angle, like we talked about before too, the kingpin angle can affect that as well, because as the tire turns, it lifts up and it moves on this other arc. And so your KPI, your caster, all those things affect Ackerman. And so in the end, it's going to be, you know, whether I can either get good Ackerman or whether I'm willing to accept less than ideal. Because typically, if you have the system set right, the small changes in the front don't matter much. Your radiuses of your circle aren't going to matter much. If you're doing a lot of high-speed driving, then you're not going to have a whole lot of sharp turns at high speed. And Ackerman is way more important when you're driving a car that's on lock, at the steering lock, or turned really sharp. So like drifter cars, they care about Ackerman, but a lot of drift cars don't have very much caster either. They have really high kingpin angles, and they kind of rotate the tire, which they have to do to get the tire to turn far enough to fit inside the chassis and a bunch of other stuff too. So, and then they have different mounting points for their tie rods. They change the angle up and down as well as forward and back to try and maintain Ackerman while they do all their drifties stuff. But for high-speed stuff, Ackerman isn't as important if it's close. If it's way out, then obviously that's going to be a problem. I turn the wheel and one tire says, we're going to go really sharp. One says, we're not going to go really sharp, and that's a problem. But if it's close, it's close. You know, it's not going to be as big of a deal until you really get into the steeper angles of the turn, for sure. And that's where building it for the use comes in. You know, there's always going to be a little bit of compromise with anything, with any engine build, with any transmission build, with whatever. There's always a little bit of compromise. You got to pick, do I want it to be, you know, really good in this situation and not as good in this situation? You know, you cannot have it be perfect in all situations. It's impossible. It's totally impossible. If you ever watch professional racing, like touring car racing or V8 supercar, I watch Australian V8 supercar all the time, and like, there's no better example that you can't have the car be perfect in any situation than watching those guys race and what they do. You'll have a car that behaves amazing on just the soft tires and then shitty on the hard tires, or amazing in the dry, not good in the wet, or really good at high-speed turns and not so good at low-speed turns. And that's just the way it is. That's all there is to it. Like, you can't get around that. So, as with anything, you got to have your design use in mind. Rally cars, good rally cars, not a lot of caster. Really good track cars, quite a bit of caster, right? Like, that's two different things. So it totally depends on what you're going for. What was the next step? So I showed you the arm. I got the strut out. I don't know if that was right or left. I just grabbed it really quick. I don't recall where the brake line is on these. Does it say left or right? It does not. Alright, so I gotta look at it, see which way is left or right. So the offset goes to the rear. So the offset goes to the rear. So if I'm on the front of the car like this, offset, this should be left. Right? Yeah, that should be left. And that makes sense because I have ABS sensor on the front and brake line on the back, and that's how this is set up. So yeah, I coincidentally grabbed the left one. Can't bitch about that. But before I do that, I keep forgetting. I want to see if these guys fit. Well, short answer is they don't. So I'm glad I spent $1,200 on them. So this diameter here is just a little too big. Actually, it looks like there's some goop on it, so I'm just catching this buildup right here. There's a little goop on it right here. Yeah, it's close though. Yeah, it pretty much fits. I just need to, yeah, to tap it in. So it's a little too tight. Not too bad though. I'll show you a picture in a second. Let me get a little love on it. See how much love I got to give it. That's it. Okay. So it is just a smidge tight around that ring. Oh, dart's falling out of it. Okay. That's in. Okay. So note to self. On the final version, I knocked that down like 5 to 10 pounds. That's it. Because it's basically a press fit. I basically made that exactly the same size as the hole, which is stupid. I was trying to get it really tight. I wanted the taper or the radius on the top of it to fit inside the radius here. So this radius right here, a little radius right there, I wanted that to fit in the radius of the body. What I was trying to do was get as much of the force distributed to the whole strut tower area or the whole strut mount area as possible, not having just 3 little contact points at the bolts or anything like that. I didn't want to have concentrations of stress in really small areas on it. It is aluminum after all. It's 70-75. It's thick aluminum. I mean, I think I got like 10 millimeters thick through most of it. 8 to 10 millimeters thick through almost all of it. So it's thick, but I didn't want there to be a lot of flex and bending, and I wanted it to distribute the load as evenly around it as possible through the whole thing. Through here. Wipe my hands off. Go look at that. They were muddy. All right. Whew. Battery's about to die. So there it is in place in the car. Let's look at the top. Can you see the top? I don't know where it's at. Yeah, there it is. It's not in the right angle. I just pushed it in place to see how it fit. It's close though. It needs to turn a few degrees. Looks pretty good. I like how that looks. That's cool. Now, will that fit the coilovers I just made? I don't know. I honestly don't think so. Or fit the coilovers I just bought. I don't think it will. Because these have a really big mount at the top. You can see it right here. It's a really big circle here, really big mount. And that's supposed to slide on the plate to give you camber and caster. Now this bolts the top or the bottom or underneath the body there, so there's no clearance issue on the outside of this. Mine is offset and it's supposed to mount inside there. So it will fit. I'm looking at it. It will fit, but I will have only a fraction of the adjusting range. Oh, they did flatten that one spot though, actually. That's pretty good. Oh, so it'll work in one direction. So I'll get quite a bit of movement in one direction, but not the other. Okay. That's fine. If you look here, it's actually flat. Trying to get to the camera there. It's not round the whole way around, so it's flat right there. This is. So that means that this should move quite a ways inside of here in that one direction. But in the other direction, it ain't flat, so it won't have a whole lot of adjustment. But the idea for this thing, the reason I made this, was for the cases like the Bilsteins, where that distance is fixed. If somebody lowered the car a lot and there was still happen to have room, like the distance it was too long or they just set it wrong, I wanted them to be able to lower it 3/4 of an inch on this, bring the strut up 3/4 of an inch. You know, a lot of guys are running, like I'm going to run flares on this, right? So now the clearance to the fender is going to be increased. So technically I should be able to go up a little higher before I find the next limit. Usually that limit is the tire hitting the fender. And so those Bilsteins are probably built around that for a GD. Again, it's not a GC. And that was the other thing. Those are longer than a GC one would be. So by moving this up, then I get that, I bring it, make it shorter technically, right? Bring it up, and it's more like a GC should be. That's a lot of smoke outside. We didn't have a fire this morning. That's a lot of smoke outside right now. Holy shit. Ugh. Oof. Holy crap. Can't see Canada anymore. What the heck? Now, what's really perplexing me about this is there's the airport, and I don't know if you guys lose a connection or not. The airport's out there. Under the cars. Whew. All right. So the airport's out there, and they frequently have the fire planes flying out of there. And for some reason, they're not flying very aggressively today. Usually, I mean, you heard one plane fly over just now, but usually the fire planes are flying continuously out of this airport if there's a fire, and they're not. That's a lot of smoke out there. So I don't know what to think about that. All right, so what I covered today. Covered clearancing the frame for this arm to make this rack work, or rack work. A little bit about this. This is long enough, probably almost a perfect length, really, to work with Williams' brackets that he made. Just this width is wrong. I have to drill some holes in the brackets, but the size of the bushings and the location on the frame rail looks like it's perfect. Like these are like the perfect length, and that's really cool. Obviously, I have to figure out how I'm going to mount it to the hub itself, and so I have been thinking about that for quite some time, and I feel like if I mount it to the back side of the vertical part of the hub, make a little mount that holds the ball joint there, then I will give myself caster. So I change that rotational axis without pulling the hub back. If I was to say put it at the center of the hub and pull the hub back, then that would move that the center of the hub. If I tilt the knuckle back, the center of the hub would come back. If I just move the ball joint mounting point to off center here a little bit, then I still get caster when I turn, and I'm not losing wheelbase to do it. The only issue I have then by doing that is that my kingpin angle does not pass directly through the center, through the center of the hub. and that's not totally ideal. Because then what you have is the where the torque is applied, if it's forward of the pivot, if it's forward of the pivot, and when you're turning it, the tire scrubs as you're turning. So if I put that point too far behind the center line of the tire, when I turn to the left, the tire now drags across the ground because now it's traveling on an arc around something instead of pivoting on the center. That's also known as scrub radius. But I can artificially induce scrub radius by putting that point backwards instead of keeping it in line with the center of the hub. So not only would I potentially have scrub radius from the angle of the kingpin being off of the, if you were to follow that line, the kingpin angle all the way through to the ground, and see where it passes through the tire, ideally you want to pass through the center of the tire, the very center of the contact patch, so the tire rotates on that point. And if you put wheel spacers on your car, like a dummy without having wider wheels, and you just push them out further, then that point moves towards the inside of the contact patch. And then when you turn your tire, now it's rotating on that point, and you're literally scrubbing the tire to turn it around. You're dragging the tire to turn around that new point. So anywhere that's not in the middle of it is called scrub radius. You can go positive, you can go negative. Negative is actually more acceptable than positive because negative is safer, but almost nobody wants negative because nobody wants to pull their tires in they always want to go out with them. So if you do go out with them, then that's a situation where if your lower ball joint is fixed, then you have to increase your kingpin angle to move that rotation point to the center of the tire some. In that case, that's okay to minimize the impacts on scrub radius, but then all those other things we talked about before, you have to deal with. The loss of camber as the tire turns, which isn't good. The lifting of the car as the tire turns, and the increase in steering weight, which may or may not be good. So there's just another thing we can talk about yet, scrub radius, and how that's affected by things. So if I do it low, if I attach the arm kind of low to the hub and I bring it down next to it, really close to the hub, then that takes that line and pulls away from the center of the hub more than if I attach a ball joint higher up off of the center a little bit. If I go higher with a ball joint and I still go back some, then the amount that the hub, or that I depart from the center of the hub, is reduced. So if I needed for some reason to push this an inch back because it's the way it would fit, if I bring it further from the center up higher, then that effect is minimized. So ideally, I would pick this up a little bit. See, I really want a slight upward angle on this arm. So if I want a slight upward angle on the arm, then that actually benefits me to have a ball joint attached higher, much higher than it would be if I attach it down where the strut connects. And you see that in some cars. If you look at a lot of cars, they'll have the upright goes up, goes out, comes around the tire, and then there's a ball joint way up top above the surface of the tire. And that's done because there's only so much room to have your front suspension. You have an engine and frame rails, and everything is wide in the front. So you only have so much room to fit all these suspension components. And so if you have to have something forward or back, it's better to have it further away and further and back so you don't have these more drastic effects. Or the control arm geometry. The control arm is going to be super crazy short because you can't have a long enough arm in there. There's only this much room for an arm, so this tiny little arm. Well, that tiny little arm, you're going to have a lot of movement. So I can have a lot of movement at the tire by putting it really close to it, and the tire moves in and out a bunch. Or I move it really far away, and a lot of movement up here is very little movement down here, right? So they move that ball joint way up away from the pivot so that even though this arm is making these big swings that's super short and you have this big change in and out, it doesn't affect you as much down the tire because it's really far from the pivot at the bottom. It's just, a little bit of movement down here, right? Where I get 3 inches up here, and I get 1.5 inches here, and I get 3/4 inch of the hub. So for me, lengthening that point, lifting it up and attaching it higher above where the strut connects, as high as I can without interfering with the tire. I'll have to put a tire on it and see what that's going to be. And then having a slight upward angle on this lower arm is going to be about as good as I can get it. Now, in actuality, this hub is not vertical in the car. When the strut's in here, the hub's actually back a couple degrees, right? We talked about caster. So we usually have about, I think this car, like I said, I think it's like 3 or 3.5 degrees of caster from the factory. And I think a lot of guys will do like 4.5 to 6 with modifications to it. That's just pulling out of my ass though. I don't recall for sure. So yeah. So if I go up. Get a smidge of caster out of it. Here, there's one. You hear that? That's one of the fire planes. That was low. That sucker's loaded. There's a lot of fire retardant on that plane. As you probably guessed, the runway's like right there. I showed you that, right? The runway's really close. And I don't mind it because it's a small airport, but they got a really long runway. And due to our location up here, it's advantageous for them to have a filling station of retardant at this airport. It's got a mile-long runway, so any airplane can take off from it. And so they have the fire planes during fire season coming in here all the time. Now, I love jets. I love all airplanes. Airplanes, helicopters, I love all that shit. So when those things come flying overhead and they rattle the house and shake it, I don't care. I'm like, fuck yeah, that was sweet. You know, and I've lived here for a couple of years. It doesn't affect me at all. Like, no part of me is ever irritated by it. But some people move next to airports and then bitch about the noise. That ain't this guy. Or they move next to a racetrack and bitch about the noise. You know, like, hey, you're a fucking idiot. You knew that track was there. You knew the airport was there. Why would you bitch about the noise? That's your damn fault for moving there. And then they act like, oh, this fucking airport's intolerable. Like, hey, moron, you moved there. Like, it's been there since the fucking 50s, and then you show up in 2020 and then bitch about the noise. Like, I hate people like that. I'm not that person. So I love living by the airport. It's pretty awesome, especially because I'm like on final. So I get to see all the cool stuff and hear all the cool stuff, and I dig it. And then when those red planes fly over, they're really cool. I always forget the name of those planes, but they are. They're an awesome plane. Take a picture of that. Woo. Do I have? Oh, I have my freaking. I'm a dummy. I'm a dummy. Yeah. What did I do with it? What did I do with it? In my car? Yes, my precious. My phone is yelling at me for being out of battery. I have my freaking power block right here. There we go. Okay, I want to take a picture of the strut mount. Oh, that's really cool. Oh, I really like that. It's just above the top there. That is really neat. Ah, I really like how that looks. I like that a lot. Here's something. This is the rear mount for the front control arm on a VA STI. Subaru went with an actual spherical ball. This is just like a ball joint. It's a spherical ball. It's sealed. But these don't have any give, right? This axis here, in and out to this, there's no give. And they went with this because these chassis just flex so damn much. And the bushings in the back of that control arm flex a lot, altering your geometry of your suspension dramatically while braking or turning heavily. And so to improve the handling, now, little known fact, the guy at Subaru that was building the WRX, the VA WRX, because it starts off as a WRX, was competing with the guy that was building the BRZ. Apparently I don't know if it's a formal hate or if it's just a work thing, a competition thing, but they compete with each other. And so when they made the BRZ in, was it 13? Everyone's like, oh wow, best handling Subaru ever. But the DRX guy was like, what? Fuck that. And so they redesigned the suspension and everything on the VA chassis. And one of the things he did was used big ass circle bearings in the back of the control arms to maintain rigidity of the suspension. If you think about that control arm, that rear mounting point, like I showed you before, if that thing's sort of bending in and out, right? Toe changes, camber changes, everything changes. And it changes under load. So it's not often changing for the best under load. So they stiffened up the car dramatically. Chassis-wise, the crossmember is super beefy. And then with these bearings and a few other things too in the system. And I wanted to run these in the car, but that frame section that I had to flatten out to get the other part to fit is completely in the way for this type of bearing back there. Completely in the way. I would have to cut that out or hammer it flat or do something dramatic to the car. And my goal for this research project here was to try and make something that everybody could do if they wanted to with one of these cars. And so unfortunately it just doesn't work. For the GD, it might work. I haven't looked at the GD yet, but I really, really wanted one of these in there. I really wanted this to be the guy. And I might still try and figure out a way of mounting it this way to replace the existing bushing that's back there right now. But I don't currently see a way of making that happen. But if I was to do so, then I would make the whole adapter where it goes to that control arm. The problem is that this is really small internally, and I don't see a bolt that would go in through here having adequate shear strength to handle the loads of the control arm doing this on it. I don't think it would work. I think I would have to make a piece that comes over this whole thing and like press fits onto it with threads in the bottom of it for a bolt to come in this way to draw it onto this so that this can handle the loads. Because this can handle load, this steel here can handle the loads. But to have just like a aluminum piece or something bolt up to it with a nut or something, you rely on shear strength or something I don't think could support it. But like I said, if I had this press fit onto another piece of steel that the arm bolted to that was beefy the whole way, I think that would work. But little known fact, I have way too many projects. I mean, holy shit, have you seen my garage? Where'd it go? I guess we'll use this one. Well, I really like the way that looks. Like, I like that so much. I might just put this on Fortune just so I can look at it. I wonder if the bolt pattern is the right size. Looks similar. Oh, it's gonna work too. It's gonna fit. Oh man, I might just do it. Even though I won't be able to move it around a lot and get a much adjustment. This is so pretty. And I need to test it anyways. I need to make sure it's strong enough. And like I told you, it was like 8 mils and 10 mils. No, I say mils. It's not mils, it's millimeters. Thick. Oh, yes. Nice. It's super beefy. So I do it. Put it in there. Now that's gonna lengthen the distance. This thing has to, oh wow, those are pretty. Wow, man, Fortune really knocked out a part of these. Oh shit, I don't have the right. I don't know if I can do it. I know I'm out of camera. I apologize for that. Not that you're just dying to look at me. But check this out. Okay, so this is the Fortune plate. It's a normal plate. You know, nothing too fancy about that. I was going to use the same kind of bolts that you tap in and they got knurling on them and it sits in the hole. And so that's what I did this for. I looked up the specs on those. So technically, these look like the right ones. This might be a little tight for those. So I need to get one of my reamers and ream it out to a slightly higher size and tap in these kind of things into it. I don't have them on me though. I forgot to get them. But check this out. This is the bolt that they have to put the upper bearing into the camber plate. They have this little sleeve on them. It's just a little it's a little cup. This is a little U-cup. Right? But just this little guy here does two things. One, it hides the knurling on the side of the freaking Allen, which I think is ugly. But it gives a cool machine look on top. But what it does do is act as a washer, not for low capacity as much as being able to turn it and tighten it. It acts like a bearing between the strut, the upper bearing plate and the coilover mount. That is, and the camber plate. That is really cool. I dig that. Dig that. I'm gonna put mine on real quick, just see how well it fits on here. Oh my god, it fits good. Oh, it fits so good. Here, check it out. Where's there an angle? Oh, because the bearing plate's at an angle. Like, what the heck? Ugh, what is tight? Actually, it's good to say an angle. I can see how well the spring fits. The spring fits in there. And I made it too tight. There we go. So I can go that far in one direction, as far as it goes in that direction. So not a lot of movement, because it only goes that far in the other. So I basically have no camber adjustment on it, just a tiny, tiny bit. That's all I get. Huh, there it goes. Not much. I mean, for that, it might as well be none. Yeah, that's easy to move. So that's all the room I get. That bearing is so big on the bottom that it just fits inside that cup with not much space. I mean, it's better than nothing, I guess, but I don't know. It goes from centered to some. when I had originally designed these, I had designed them around the bearing that they use on, I think they're BCs or some other ones. It's a little diamond-shaped, little kind of teardroppy diamond-shaped plate, and it attaches in just 2 points across here. And that one had a lot more movement in it, but I think manufacturers have gone away from that one because it's potentially not as strong, maybe. Because I see that plate less and less often now. So now, obviously, this is for the GC and the GD, right? Not a lot of movement. Now, on the GR and VA, this diameter is a lot bigger on those cars. And so on a car like a GR VA, it would have significantly more adjustment than that on it. That ain't much, but it sure looks good inside the car. God damn. How far is that? 3/8 of an inch? Oh, toolbox. All right, there it is. You see the lines? That's the total travel. That's all I got. I said 3/8. That's a quarter. I gotta stop lying to the wife. It's throwing off the measuring. That was a dick joke. Anyways, that looks really good in the car. I really like that. Looks when it's up, taken out of the strut tower there. Well, I'm gonna do it. Not today. But I'm gonna do it when I do my next suspension tweak, because I gotta get the screws to hold these in. But I'm gonna put them there. Even if I can't adjust much, I really like the way they look, and it's something I made. You know, something that I did. So I'll run for a little while. I want to see that they're strong enough. So I'll definitely put them on and then go take it off some rad jumps. Just kidding about that. I'm not gonna do that. Boy, I'm hungry. I don't remember eating anything today. Oh, I had some Ritz earlier. Yeah, why am I hungry? I had like you know, almost a whole sleeve of Ritz at 9 a.m. Wife and I have been on a diet. Not like we're dieting kind of diet, but like we just decided to eat less stuff kind of diet. And that way. That diet has consisted mostly of bread, right? And I mean, careful fitness people. What? You're eating carbs? That's pretty much all we eat, really. Just bread and veggies. I have meat too, don't get me wrong. I have meat on occasion. Every couple days. I got a freezer full of steaks and ground beef. I definitely utilize those frequently enough. But I'm down to 204 of all things. I was at I was like 2.25. So I'm going to put these plates in a different angle. I'm going to put them in a way that gives me the most amount of caster and the least amount of camber. I'll lean it back. Lean back. Lean back. Nice. Now, you saw me banging off the fender there. I got a wide body kit for it, so I'm not too concerned about it. That gives me caster. I feel like that's not enough. If I go this way with it, it gives me caster and camber. I don't want that. I'll put it this way. People are gonna freak when they see it. Go gadget arms. I mean, I could bring the car down and make it easier on myself, right? What fun would that be? What's the point of having a 6'6" wingspan if you don't use it? All right, I want to exaggerate. 6'5" and 3/4. Sorry. Fuck yeah. All right. There's the other one. The other fire plane. That's one they were at. It must have been dropping retardant or filling up. But I kind of want to get new bolts. These are so ugly. I almost want to take them and get them recoated. Lean back. Lean back. All right. See how many degrees I got sitting there. Obviously it's a full extension, I realize that. What happened here? Oh, it broke. Oh, that's sad. Alright, so I have 1.5 degrees of camber at droop right now. It obviously will change when I pick it up. So 1.4 degrees right now, 88.6. Just off the hub flange. Looks like I'm about vertical. It's obviously a very crude measurement. It's not super accurate. But what I want to see is, what does my camber do when I turn the wheel? Move that a little bit on accident, put that back. Back to here. Back to where it was. Okay. Turn it. So it loses camber. It actually went up for a second. It came up a little bit. Does that change it? You can feel it turning it. Actually, I'm going to move this in here. Like that. Wow. In fact, that's good. I'm now positive camber. This is tight. This is all tight. This is. Can I move this? I move that some more. Adjust it on top. Yeah, I went positive camber. Negative camber. Another plane. Again, I understand this is a droop and not at ride height, but I just wanted to demonstrate how that works. All right, fully back on that. $89.3. $90.5. Oh, that's a little loose. Let's tighten that up. Come on. Okay. 88.2. 87.9. So I gain camber till here. And I lose it. Interesting. $91. 88. 87. 88. So I get an initial gain in camber as I start turning to about there, to about 30 degrees, if even, and then it just dumps camber from there on. That's less than when I had the, I put the strut all the way back. It's less than when I had the strut forward. Oh, man, my neck's just cramping up today. I haven't seen any comments in a while, so I assume nobody's here. Looks like I have about 4 degrees of caster. About. using this as a straight edge. Trying to get straight edge from the pivot point on the ball joint, the center of the strut where it mounts up top. Just want a straight there. Again, this is just generic. This is not totally accurate. This is just to give you an idea of about where I'm at. $15.5. Well, that's what I said earlier, right? 13 to 16 or something like that. So this is about 15.5. Somewhere in that range. 15.5. What's that arm at? I gotta do it. I gotta do it. Hey man, thank you very much. Appreciate your support. $20, man. Jeez. Thank you very much. I mean, I should be paying you for sitting here for this long. You've been here the whole time. Damn it! Measuring that. Like I said, not accurate. It's at full droop right now. It's not at full ride height. But when this arm gets longer as I pick it up, that indicated angle is going to get bigger. And that's upsetting because I don't want it bigger. I could use a GC length arm. I initially went with the GD arm because I wanted the wider track. But I could put a GC length arm in it, or a GD wagon, same length arm. And they make GD wagon arms that are aluminum. So if I find the aluminum ones, it would be aluminum like this, but it'd be a GD wagon arm. I could do that, and that would bring that lower point in, pull that ball joint in a 1/2 inch. If I pull that ball joint in a 1/2 inch on the bottom, that would make that kingpin angle we're talking about a little more vertical. Draw that in. And I'm not opposed to that. The wider track has actually posed a lot of problems over the years with getting tires to fit and the fenders and all that shit. But like I said before, I'm eventually going to go with flares. I have flares for it. I have wide body kit and flares. I can't decide which one to use. I think I'm going to use the small flares, but that gives me lots of room, you know, another inch or so of room. I have to build a custom arm. That's what it boils down to. I have to build a custom arm for the upper. I use Williams brackets, get them on the frame, get those points, build an arm. But when I build the arm, I will add a point that holds the strut. I'll have to make a foot or something for it. There's no reason to use the Model 3 strut bottom to go around the axle and make a bracket to adapt to the lower control arm if I'm going to make an upper control arm. If I make an upper control arm anyways, I might as well just attach it to the upper control arm. That's not as much movement as I thought it would be right there, though. The other thing I was thinking is that if I just if I don't make the strut rigid, where it bolts to the hub, if I put it on a pivot and only put it on like one bolt on the hub with a crush sleeve and a pivot so that it's free to move in and out on its own, then when it rotates, that's no big deal. It doesn't affect the geometry because it's going to be pivoting on the ball joint. Is that true? No, that might not be true. It's definitely going to pivot on the ball joint, but yeah, that's fine because it swings up there. So if I make it pivot on the ball joint and just put a soft mount essentially on here, then I don't have to worry about losing my motion ratio because it stays attached to the hub. What I have to worry about is the strut swinging back and forth inside of here as I turn it and contacting the arm. If this hub rotates too far, that strut pivots out and away, and it could hit inside the arm unless I put the arm at the right point where it's at the narrowest point of the strut. Man, see, there's so many things. So many things to think about. What's crazy about it is people just go fucking hog wild at modifying suspensions. And oftentimes, they hurt it without realizing they're hurting it. They're like, oh yeah, I added camber, it's fucking great. But when they did it, they end up hurting a bunch of other aspects of their suspension. I've had a lot of guys that lower their car. Oh, I'm getting a lower center of gravity. It's going to improve my handling. And their handling drops dramatically because they've moved the roll center to an area that's not even within the bounds of the suspension. Where is my other socket? What do I do with it? My other wrench. Is it under the computer? No. I don't know how I can't find it. My shop's immaculate. Oh, there it is. Was it 17 or 19? It might have been 19. Which I never had at the first place. Alright, I'm just going to do this last part, and then I'm going to show you guys some of the electronics associated with the electric stuff. How often do you recommend you go between alignments? Well, pending damage or excessive wear, your alignment shouldn't change. Now, if you smash a pothole and you just feel it in your bones, you know, you can consider at that point, maybe I should check something. The toe would not change unless something bent. Camber could absolutely change if the eccentric bolt had enough force applied to it from the impact to make it rotate some. It could change if the strut bent. You know, for the most part, your alignment's not going to change on its own without, like I said, something either coming loose because somebody forgot to tighten something, or wearing or breaking, like the springs are sacking out because you got swifts on it and your alignment changes. You know, things like that, you would need to change it. But otherwise, like, you shouldn't need to like just redo it all the time. That should never be a thing. lot of room in there. If I build a soft mount for this thing, come on. Look at that. Alright, I'm going to bring the camera over here so you can see this. I think this is interesting. Whoops. Is that working? Oh, there's a big stream delay. I don't remember that happening. It's on this ladder here. What's on here? Sorry, I'm finding my thingy now. There we go. Got it. Okay. So what I want to show you, I think is interesting. We're going to try and look at the strut inside the arm. Bring my OBS so I can see what you guys are seeing. All right, I'll bring it up a smidge. It's drifting down. Okay, right here. So right now I'm at full lock on it. I'm gonna hold this arm right where it is. I'm just gonna hold it right here. I'm gonna pick this thing. Now see that strut moves away from the arm inside and moves to the left, as you expect, because it's bolted to this hub. Now here it is at the other side. It's not quite hitting this arm. It's got a little bit of space. Now I go back this way. Oh, it hits the arm right there. But there's no way I'm turning the tire that far. That's that's really far. Okay, so it's almost like there's enough room, even if I leave the strut connected, but not with both bolts. Both bolts I wouldn't do anything. I just break things off the car. But yeah, it's like there's enough room inside of it for the car to turn. without it touching. I mean, I can move this forward a little bit, and then it would almost fit in there. With the exception of, this has got to go back some, so it would get to a narrower part in the arm here, if I use the RX-8 arm. So I could change this foot out with one of them that just has the single bushing on the bottom, the single round mount on the bottom of it, and then make a bracket that's got a bolt that goes through that bushing and just bolts it to here on that one point. It'll still swing with it, but as long as this room inside this, the room inside this control arm is large enough to permit the swing, then no problem. Now, if I have swing with travel, that's where I got to be careful now. If I go up like this, oh, you know, that's not going to matter because this is going to move up with it, up and down with it for the most part. It's going to have a slight relative motion to it, but if I put it in the right point, it's going to be at the narrow threaded body portion. You can sit right here in the middle of it with a mount. I won't lose an appreciable amount of motion ratio. I'll lose some. But if this is damp for a GD, then that actually will work in my benefit. If it's got GD damping on it for something that's heavier in this car, losing motion ratio is definitely an advantage on a highly damped shock. So that'll be beneficial, honestly. And then that makes the whole adapting thing a lot easier. I can make the mount be a ball joint receiver and the lower strut mount bolt to this, and it just changed the fulcrum up to above it towards the front here, which reduced that kingpin angle dramatically. I mean, quite a few degrees. Ball joint receiver up here, have this up a bit like this into the receiver like that, a little bit of upward angle on the arm, and attach the strut to the existing knuckle. And in theory, I could make a whole kit that anyone could fucking do this. And with that lower shock mount, I bet I could find a shock on the factory, or on the factory, the hell am I saying? A factory-made shock from another manufacturer that would mount between those 2 points. And then have that kind of bearing on top. It would be, well, I need to do some bearing because of the fact that it still pivots off the knuckle. But people make coilovers with the normal foot on the bottom, like my Corvette, I think, has that in the front. The Corvette's actually got a shaft that goes through it and bolts down. That'd be awesome too. I actually use the Corvette lower foot because the Corvette shock is really short. Use the Corvette lower foot, and then it has a bar that goes through it, bolts with 2 bolts to a platform, so I can make a platform right at the back of this, and the strut would bolt right to that platform. This fits around it to a ball joint receiver right up here on top. Kingpin angle comes up. I can push this back a little bit, get a little more caster out of it, which is totally fine because this is back. And if I wanted to, I could even push that mount off center just a smidge, because that would be fine too. The shock would be all to the right side if I want it needed. I could push the shock off to the side some. It won't affect the motion ratio, and it won't affect the way it turns. And I could push this back some and gain some more caster out of it. And use RX-8 arms that you get on eBay for $60. $60 arms. And all I have to do is make a correct size receiver that comes off of here. I just contact Williams and say, hey, dude, cut me new plates with the shorter, with the narrower mounting points on it. So the big question now is, do tires fit? If I have this right here, will a tire fit over it? The inside of the wheel is usually really close to being up here on the coilover. So this is a slight upward angle. It's going to be, we'll say like this with the receiver. Will a tire fit over that? Or will this be in the middle of the wheel? It's probably right in the middle of the wheel, isn't it? Because the brakes and the wheel diameter. Is there room for a wheel? Doesn't look like it. To make room for a wheel, I have to move the ball joint back more. If I move it back more, then that moves this narrow triangle towards the strut more, which gives me less room to turn again. And if I then tried to compensate by moving the strut back further, on here, if I turn the strut back further, then that means I get wider swings with it, and I would need a bigger gap in here. So if a tire doesn't fit, with this being somewhere around here-ish, like it is now, like, you know, like this, if the tire doesn't fit and I don't have any room, then I just have to do a custom upper arm, because this would never work. Or I have to figure out a different way of attaching the strut. I have to attach the strut to the arm itself and not to not the knuckle. Now, what I don't like about that, though, is this arm isn't huge. Like, there's not a lot of meat on this arm. So I'd have to make my own arm. That's what it boils down to. Driving a tire. It's gonna have a wheel on it too. Snow wheel, but it's a 17. I would like to be able to run 17s. If I have to run an 18, then I guess that's what has to be done. But I'd like to be 17. Okay. All right. Does the wheel fit? Off. Not exactly. Not exactly. By not exactly, I mean no, not at all. Close. Wow, why is that hidden? It's close. But it's not adequate. If I had an 18, it would probably work. If I had an 18, it would probably work. So that means I have to bring that mount point away. or down more. I bring it down more. All right, that's it. That won't work. That will not work with that arm. So the correct way would be custom arms. On the bright side, that means I don't have to ask William to change anything on his design. His stuff will work. So I can use his mounts to make my own arms. And the benefit to that is that the arm can be big enough and beefy enough that it can handle the suspension loads on it, whereas this RX-8 arm would not be able to handle the loads of the suspension on it. It would just fold. And I need something that's going to handle the loads. It'd be awesome if I had an existing arm already, but not a big deal. I could definitely do an arm. The issue is this damn knuckle. This point right here is too high. It's in the way. If I could attach the ball joint right here in this space, then I would be in really good shape. I have to modify the knuckle. I'm not opposed to that either. You know, like if I could even make it with this arm and a modified knuckle, I'm okay with that too, because I would love to add some drop. You know, lift the bearing up in the knuckle an inch. Drop knuckles, as you've heard them called. Make it a drop knuckle so that my arm geometry stays more correct as the car gets lower. And then by doing that, it lifts the wheel up in relation to this mount point, which doesn't matter because it's going to be a different mount, right? But we're lift it up and provide more room on top to attach ball joints and control arms and struts and all that. So I could technically still do RX-8 arm, custom knuckle with a mount for the strut that's close, and the ball joint receivers up here for this to attach to, and yeah, that'd be cool. I would not be upset to do that. I mean, really, you could even do this arm upside down, flip it over, and have the ball joint underneath and the nut on top, because it's not handling loads in any direction other than in and out at that point. So it isn't like I were pulling a ball joint out or pushing it in or nothing like that. There's no loads on it other than holding the top of the knuckle in that plane. So I flip it over and have the shaft going up and slide it into a pocket in here and just nut on it like that. I just said nut on it. I should have done that differently. Too bad. I got you on here. I don't know how I'm gonna get you off, but boy, what am I saying today? Yeah, go nose first. Yes. I think that's how we did it. I think. Flick the car. The other option is hack this off. Just modify this knuckle, hack the top of it off here, leaving just this one mount here. And then making an attachment that bolts to here that does both of the features that I want. Part of it goes up where this is, have a ball joint receiver, and then the back of it sticks out to accept the except the strut. And that can also be done. Just set it up so that I hack this off. I slide whatever it's going to be, piece over it, bolt it in, but then also just weld it. Weld it to this part, weld it here, make it permanent. Just use this for location, right? This is a precision. I say precision. Look for the rest of this shit, right? But this is a precision part of the hub. When they manufacture them, this is specific, the right width, the right location, and all of that. So I just cut this part off, use this to locate and as a strong point. This goes up really big right here. You see this reinforcement because the loads of the strut are transferred, or the suspension transferred through here into the strut. And so if I attach it down here, I don't have the pivoting, as much pivoting as I would have like this right here. If you think about it, if I hit a curb, this wants to bump in, right? It's going to bump into the strut. And so that would cause this to bend if it wasn't reinforced enough. So they have that really reinforced, which I don't care about because I'm going to put a ball joint on top and it's going to be attached down here into this thick reinforced area. So I won't be losing anything by doing that. All the forces are going to be here. So I could do that, really. I think I might have an extra hub too. You can buy brand new hubs, knuckles for pretty cheap. Honestly, I think like 130 bucks or 160 bucks for a knuckle. So I could buy myself a new knuckle, put it on my car, then take this one off and modify. Oh, I have another set of knuckles under there, I think I have another set of 5-in-114 hubs and knuckles under there. I could do that. And then cut that off, make it flat or angular. Slightly angled actually. A few degrees off would be great because I want this to be a few degrees like that. So I could set the cup in at a bit of an angle if I had to go down into it. If I did a thing that this went into from the bottom, it popped into a thing. So a receiver on top, and the strut comes out and goes through here and bolts down. And it was sitting there like this. It'd be at this angle now. Down makes more sense, but it makes bolting this in more difficult, right? Like if I try and put this in here somewhere, then how do I get the nut in there? It's not very fun, honestly. If I do it off center, then I'm putting that line off center of the hub here. I don't want that. I'm adding unnecessary scrub radius in a weird direction. So I still want to be center line. But if I cut this out, and this is like live in this space here, And it can live in this space where this is. Then my bracket attachment can come up here like this and go over and attach. That's going to be pretty beefy though. Be easier to make a knuckle. Probably. 400 per arm. Let me take measure how long my front struts were before and make this one similar. So that's a good starting point. I'm going to use this laser to get the length. So the laser tool is pretty badass. Check this out. Can you see that? So what I'm going to do is I'm going to measure from this top hole to the bottom of that cup using this laser. So there's a line, tells you where it measures from. And then I put the laser light where I want to reflect off of to give me the distance. Maybe put this on the ground or hold it differently because it's hard. .1 foot 4 3/4 inches. So 1 foot 4 3/4 inches. Okay. And this one. 1 foot 2. So I can make this longer. Foot 3. Was there enough in here? Oh yeah, there's plenty in there. I'm thinking about that now. I think actually the GC struts are longer than GD struts. Now that I think about that, I think that was one thing that I recall. .4 1/2-ish. 1 foot 4 7/16. Where's can go there? I'm getting really off of that. Huh. Getting really far in there. That was the front, right? Yeah. Let's measure one more time to be sure. Yeah. 4 7/8 to this point. Now this is a thinner flange than that strut, so really it should be shorter than this. It should be 1 foot 4 1/2, which is probably shorter than this now because I moved it. Oh, you got me straight too. Actually, let's fix that. 4 1/2 right there. There's a lot of unused thread up there. But, I mean, that's a starting point, but that seems long. Like, that doesn't even fit. That doesn't make sense, does it? That's way off. You gotta pull it down even. I mean, maybe. How much compression I get. Long ways. What was the spring rate on this? This one was what? I think they were 5s, but I don't recall. 450. It's 450 pounds per inch. This car, I believe, get my phone. I believe this car was 916 each corner in front, and 7 something in the back. 916 times 2 is 1832. And it's either like 670 or 760, probably 670, which is 131440, which equals 3270. I don't think this car weighs quite 3270. But, so we'll say it's 900 pounds at this corner. That's 2 inches. So if it's 450 an inch, I'll have 2 inches of compression after I put the car on the ground. And, oh, actually that makes sense because the tire was here. And that actually would be fine. Yeah, it might even be a little low. We'll see. So we'll do that. We'll give it a shot. I have scales, and when this car is back together again, I will put it on the scales and get the corner weights, get the accurate corner weights for it, and then tune the suspension based on those weights and other geometries I'm able to find out during all this. Top's not bolted in firmly, it's loose. Alright, so this is my distance that I have now to test my, this is the other part of the electric radiator conversion, the tie rods. The tie rod's long enough. That was another fire plane. You can tell by the engines. I don't recall which ones they are, but they have a very distinct sound. So this is a tie rod, inner tie rod for a Lincoln? I think it's for a Lincoln. I went on Moog's site and looked up all the tie rods that they have. You can look them up by fitment, by your car if you want, or you can look them up by thread pitch and length and everything. So I bought like
Yeah, I'm an idiot. I realized that I lost the camera, but forgot that that was tied to the audio. So I'm a dummy. I've been talking to you guys for a while, like a moron. I even started yelling at one point, thinking, well, they can't hear me there. They have to hear me over here. But I never unmuted this camera. Oh, just to fill you in on what happened if you're still here through all that blank space, which is a video killer by far. The factory inner tie rod is the wrong thread pitch here to go into the VA or the electric rack. Everyone knows that when they do the STI swaps, they know the thread pitch is different. This one's different too. This one's M16. People say the VA STI, the 15 STI is like a 20 or some shit. I don't know. But the factory inner for the VA WRX is a 16 by 1.5. So that's the same thread pitch as my tie rod, but it's different diameter. It's large diameter. So we make helicoil kits, and the helicoil kits usually go 2 millimeters difference in diameter. So in theory, I could get an M14 by 1.5 helicoil kit, and the threaded size is often going to be M16 by 1.5, and then you put your insert in and it brings right down to that 14. So I think if I get a 14 helicoil kit, I'll have to look at the drill size and all that shit. I'm pretty sure I can just thread in the helicoil kit into the end of the steering rack and use the factory tie rod end and from the GC, and that would be a really easy fix for that. I did, and I said this earlier, but you guys weren't here because I wasn't there. I got this other tie rod from a Lincoln, and it's the right thread pitch on both sides. I used Moog's website. They have all the tie rods on there. You can look up by thread pitch, inner and outer, male, female, and the length. And I didn't know where they measured the length from. I don't know if they measured from here or from here. I didn't know what they did or from here. And after getting one and measuring it, I still don't know because it doesn't match any of the measurements that they fucking had on the site for length. Now, when I ordered a longer one from the first one I bought, I got a longer one. So I know that it's somewhat accurate to something, but I don't know what it is. So I bought this one. It's the right thread pitch to fit into the 20 WX rack. This is the right thread pitch to fit in the outer tie rod. It's just a smidge too short still. The factory one is here for my car, and you can see it's just too short. So once I figure out what they're measuring it from, and I'll know what this one's going to be, and well, I guess I'll just add on with the differences here, another inch. So I just need to find one that's the right thread pitch. It's basically an inch longer, inch and a quarter longer, and then that should in theory work. This one is the VAWX one, and you'll see here it is quite a bit shorter. Yeah, it's quite a bit shorter. It actually starts where the threads end on the VA, so it's just too short. And I actually bought one that was shorter than this initially. So Kenneth, there's a stream delay too, so it's gonna be like 20 seconds after I said it before you hear it. I had it. I thought I had it with this guy, but I didn't. All right, I need to take a break. I need food. It is 2:30, and I've had some Ritz today, and that is it. So if you sat through that fucking 20 minutes of silence, you are amazing, and I appreciate you. If you didn't, I don't blame you. So I need to eat some food and reevaluate my life. I'm going to go through the catalog and see if I can find one of these that's longer by an inch, if they have it. And then I'm going to work on another video and video series that I've been trying to do on how to make stuff. So I'll do that. Maybe I'll do a live feed while I'm doing it, So like I'll have a live feed of it happening, and then I'll eventually edit the video and put it as a series so I can time lapse using the shit. And then I'll have 2 videos on the same thing, but one of them will be more condensed, and one of them I can interact with you guys on. Maybe I'll do something like that. But in the meantime, I need a fucking break and some food. So thank you for sticking around. If you did, if you didn't, like I said, I don't blame you. I appreciate you anyways, even though you're not going to hear this. And I'll be putting this car together some more this week. I just got to get some stuff like this ironed out so that I can actually align it. I'll be putting the engine in next week, putting the rear suspension in probably maybe tomorrow morning after I get out of class. I might do some rear suspension stuff, or I might spend the whole day doing homework that I got to do since I'm going out of town this weekend. So I don't know yet. We'll figure it out. By the way, appreciate you guys. If you missed the part where I bolted this in the car and showed the picture of it, it looks really cool. You should go back and check it out. And you get the right screws for this because I'm going to use this. It's beautiful. It looks really cool in the car. I don't like how coilovers look when they're in the car, that flat camber plate, and then you got the body coming up and there's just this big gaping hole there. I don't like it. This totally gets rid of that, and I totally dig that. I really do like that a lot. So I'll probably put that in anyways. Oh, but if I do though, my strut gets that much shorter, and I don't have that much room to spare. Fuck. What if I put this between my coilover, and then there's just this big hole with all these slots, and you gotta look inside to see where the adjustment is on the coilover. That would fix my coilover length issue. Would have the nice pretty thing on there. What I should do is actually just make a fucking insert that's bigger, open around or something. Maybe beautified or something. That's open on top so that you do run it as a spacer between the coilover and the car. I can make it out of thinner material then too because it doesn't have much strength. But it can beautify that whole section. That might look kind of neat. It'd be strictly something to make that area look nice. I feel like they just come when there's a flat coilover plate under there and everything. This would fill in that void and give it like a finished look. I could even make a little insert or something that you can boop, 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 boop. I don't know. It'd be nice. It'd be fun. But I have between projects. I gotta tell myself that all the time. I go like, oh, I got this idea, and then I have between projects. So, anyways, I'm out, guys. Have a good one. I'm losing my voice, anyways. I will see you later.